Okay, so this next learning target that we have in Unit 1, which is basically just working with expressions and real numbers. Real numbers meaning every kind of number you could think of, fractions, decimals, integers, whole numbers, okay? So we're not going to start out with whole numbers. We're just going to jump right into, these are the three we're going to focus on. Integers, okay, fractions, and decimals. And this is a really good way to kind of start the year out because you're going to see these kinds of problems spattered throughout the year, and I don't want it to get to the point where, oh man, I have to solve this equation, but it has 1 2/4 in it, and have you freak out about that. Okay, so let's talk with integers first, okay? You should be pretty fluent in these by now. Obviously, the rules of addition have you talking about same signs. So it all has to do with the signs when you're adding and subtracting. Okay, so we're going to talk about the adding and subtracting rules versus the multiplying and dividing rules. Okay, so we can split them up like that. You know that if you are adding two numbers with the same sign, okay, I made my kids last year learn this little song. Same signs, you're going to add them, and you're going to keep the sign that you added, okay? So that goes for a positive number, like a positive 3 plus a positive 8 is a positive 11. It also applies to your negative numbers. A negative 3 plus a negative 8 is a negative 11, okay? So when the signs are the same, you're going to add and keep the sign that they are, okay? So let's talk about when the signs are different, okay? So your different sign would be like the 3 plus a negative 8, okay? So when they are different signs, you don't add, you are going to subtract. Okay, and then remember from last year, I mean, this is really just a quick review of this. You're taking the sign of the larger number, right? So if I look at it as I have 3 positives but 8 negatives, 3 of these positives can cancel out 3 of these negatives because those are your neutral pairs and leave you with 5 negatives. Okay, so that's why it's more of subtraction than addition. So even though there's a big old plus sign there, do I subtract? Yes, because that is the rule that sometimes addition rules require you to subtract. So what if I just switch this around a little bit and made the 3 negative but the 8 positive? Well, you can apply the same thinking up here. 3 of these negatives can cancel out 3 of these positives, which will leave you with 5 positives. So that's what take the sign of the larger means. So when the signs are different, you will subtract, okay? And then subtraction is just going to be kind of like if I were to look at it as, 3 minus 8. We know that there really is no such thing as subtraction in algebra. The actual laws of subtraction are rewritten in terms of addition. So we don't really subtract in algebra. We always look at it as adding the opposite, right? Okay, so we are at the point where you're not going to have to rewrite this. If I were to ask you to rewrite this, don't look at it as 3 minus 8. Look at it as, or minus a positive 8. Look at it as 3 plus a negative 8, okay? If you understand that, we are going to be able to go right to 3 plus a negative 8 is a negative 5, okay? So if you see a subtraction sign instead of an addition sign, you do not need to rewrite it like that, okay? So just 3, you can say it, actually, and here's the thing. If there's no such thing as subtraction, then I don't want you to say minus. So looking at this, don't say 3 minus 8. Say 3 plus negative 8. That's a positive 3 and a negative 8, okay? So then what if I had a negative 3, not minus 8, but a negative 3 plus a negative 8. Then I go and I look back up at the rules to see if the signs are the same or different. Here the signs were different. That 3 was a positive, the 8 was a negative. That's why I subtracted, right? So here the 3 is a negative. The 8 is also a negative, okay, because that's not a subtraction sign, that's a negative 8. So then this rule applies, add and keep. This problem is the exact same problem as this problem. So this is negative 11, okay? That's your real quick review with adding and subtracting integers. Multiplying and dividing is even easier, okay? The rules for multiplying and dividing, there's no trick to them. If it says multiply, multiply. If it says divide, divide. So if I have a negative 5 times a positive 4, okay, that's going to give you, remember, this has nothing to do with the sign of the larger, so you don't want you to have that in your head. If there's one negative, your answer's negative. I'm really flying through this, okay, because I know you worked with these a lot last year. Okay, does it matter if the 5 is positive and the 4 is negative? Nope. Is one of them is negative, your answer is negative, okay? But the minute I make them both negative, that's when your answer becomes positive. And so is a positive 5 times a positive 4, a positive 20. So we can kind of say a generalized rule about these two. If the signs are different, so if you have different signs, it will be a negative answer. Here the signs are both the same, so if the signs are the same, then it will be a positive answer, okay? Then you have to start thinking about what happens, though, when you get into having to multiply more than one integer, like 2 times negative 3 times negative 4, okay? So the way you could do this is 2 ways. You could literally just do it in order. The commutative property says it doesn't matter which ones you do first, right? I could do 2 and 4, 3 and 4, 2 and 3. Some people like to just go in the order that it appears, which is totally okay. 2 times negative 3 is negative 6. Negative 6 times negative 4 is positive 24. Some people like to pair their negatives up. I would like to do my negative 3 times negative 4 and get a positive 12 first, and now I don't have to deal with the negative. Some people get this. Totally ignore the negatives altogether. Meaning, I'm going to multiply and get the numerical answer, and then I'm going to go back and look at and see what the sign would be. So 2 times 3 is 6. 6 times 4 is 24. They're going to put a 24, and then they're going to go back and say, how many negatives do I have? I have 2. Okay, so this same sign, different sign rule doesn't really apply when you have 3 or more terms. But if you think about when the signs are the same, meaning 2, which is an even number, you get a positive. So if I have an even number of positives, then they pair up and make a positive, or negatives, then they pair up and make a positive, yes. It's kind of like me saying if there are 31 kids in this classroom, and I say find a partner, 15 of you have a partner, there's one left out. So this would be like 30 kids in the room. Everybody has a partner, your answer's positive, okay? So what happens, though, the minute I take that 2 and make it negative? Okay, obviously it's still going to be 24. Then the person who wants to go back afterwards and do the sign separately is going to say 1, 2, 3. Oh, there's 3 negatives. 3 is an odd number. That must mean that not every negative is going to have a partner. There's going to be one left out, and that one is enough to make that negative, okay? So that's kind of the general rule, the good little shortcut. If there's an even number of negatives, then your answer will be positive because everybody will have a partner. If you have an odd number of negatives, somebody's left out, and that's a negative answer, okay? So that's as far as we're going to go with integers. We're going to move on to fractions right now, okay? You should be pretty well versed in fractions, I'm hoping, although, you never know. So let's just do a quick type of review. And here's the deal with fractions. We're not just talking about fractions, we're talking about positive and negative fractions. So we need to do a quick add, subtract, multiply, and divide. Okay?